In the last videos, we have discussed about normalization data scaling technique. Now, let's see what is the problem with this normalization, and then let's move on to the other data scaling technique, that is data standardization. Okay, so in normalization, what we are trying to do previously, the feature scale can be anything. So after applying this particular normalization, what is happening? Now the feature scale is moving in between 0 and 1. And how we are doing that? And that we are doing with the help of these min and max values. Okay. And we are trying to apply this specific formula, that is x minus min by max minus min, which is making the minimum of the whole data to 0 and the maximum of the whole data to 1. And remaining data will be distributed in between this 0 and 1. So if we are trying to see graphically, so our graph will look something like this. Let's say this is my input x and this is my output y, and this is the data distribution that I'm having previously in the original data set before scaling. Then this is the corresponding minimum for that, and similarly for this whole data, this is the minimum, and similarly this is the maximum. And after applying normalization, what is happening? This whole data distribution is getting fitted in 0 and 1. That means this minimum is becoming 0 and maximum is becoming 1, and between this 0 and 1, whole data is getting distributed, and it will look something like this. Now if you observe, this minimum value is at 0 and the maximum value is at 1. But do you guys see any problem with this? So if you carefully observe, there is one small problem with this normalization technique. The problem is that it is highly affected due to outliers. Okay. So, and what are these outliers? So we might have discussed in the previous videos. So I'll quickly recap this and I'll tell what these outliers are. Basically, if we are taking, let's say, height. So let's say if you are taking some specific feature that is height. In height, the range of height will be maybe something from 4.5 to 7 at max. So let's say this is the height range in general. So like if you are collecting some real world data, most probably the values will lie something in between 4.5 to 7. And like what can happen is, while collecting this particular data, the height value can be very minimum and it can be very maximum. Like let's say in the collected data we are having height of 2.5 and there is a height of 9. Okay, so these two values seem very awkward and these are very apart from the normal data points that we are seeing, right? So most of the points will be lying in between 4.5 and 7. The values that we are having are 2.5 and 9, which are very different from the existing points, and these can be due to some human errors or in special cases. So in this whole world, there is a guy with 2.5 feet high. There might be there, we might not know, but there might be there, right? In the similar way, there can be a guy with 9 feet. We might not know, but there can be a guy with 9 feet. So like that, these might be some genuine points, or it can happen that these might be caused due to some human error. So in both the cases, as these are very different from the existing data, these are called as our outliers. Okay, and these outliers can most probably be min and max values. Okay, and if you observe on which values the normalization is dependent on, these min and max values. So what will happen? Let's try to see. So here if you observe, this is the minimum value and this is the maximum value, and let's say these round points are the outliers and this is the normal data distribution that we are having. As these 2 points are very different from this data, this we can call it as outliers. And if we do normalization on this, then the minimum value will be over here and the maximum value will be over here, and the remaining points will be distributed in very small range. Let's say these are distributed between 0.4 and 0.6. We are having a range of 0 to 1, which is itself is a small range, and within this we are limiting these all values. That let's say we are having so many number of data points over here, so we are limiting all those values within the range of 0.4 to 0.6. So this is the main problem with this normalization, and it is highly affected due to outliers. So that's why we'll move on to some other technique, that is standardization. There, like standardization also will get affected with these outliers, but not as much as these normalization technique. Okay, so in standardization, what we are trying to use, we are trying to use something called as mean and standard deviation. So these mean and standard deviation are not highly affected due to our outliers. So if you observe, so this is the original data that we are having, let's say, then the corresponding mean for this data might be present somewhere over here. So this is my mean, right? So this mean, I'm trying to change it to 0. So now that mean point is over here and the remaining points were distributed around it with a standard deviation of 1. So this is what we are trying to do by applying this standardization. So what we are trying to do, we are trying to make the mean to 0 and we are trying to make the standard deviation to 1. And how we are doing that? Let's say if you are taking height column, most probably all the values are lying between 4.5 to 7 for suppose. Then I am writing several values. So let's say we are having several values like this, and on this, let's say the mean is 5.5, and for this the standard deviation that we are having is, let's say, 2 over here. So this is the mean and this is the standard deviation. Now we are trying to make this mean to 0 and standard deviation to 1. So now let's concentrate only on the mean. So how can we make these data, like previously the mean of this particular points is 5.5. Now how can we make this to 0? We can make that to 0 by simply minusing everything with the previous mean, that is mu. That is 4.5 minus 5.5, 5.2 minus 5.5, and 5.5 minus 5.5. Like that, on minusing each and every value with this specific 5.5 will make the mean of all these points to 0, right? So now this data's mean will be 0. And how to make the standard deviation to 1? Because the standard deviation will still remain the same, right? We can do something like this. We can divide it with 2. That means the previous standard deviation, whatever it is, we can divide it with that. Now for these data points, the mean will be 0 and standard deviation will be 1. Okay, and the formula can be looking something like this: xi minus mu by standard deviation. So these are the previous mean and standard deviation of the original data that we are having. On applying this formula, what will happen? Like the mean will become 0 and standard deviation will become 1. And we know that these mean and standard deviation are not highly affected due to these outliers, right? So because let's say these outliers are present, then the mean will lie over here, and if these are not present, the mean might change a bit like this or like this, but it will not get highly affected due to these outliers. So that is the idea of this particular standardization technique. So I hope you guys liked this video and understood everything regarding this particular standardization. And if you have any kind of doubts, you can comment down in the comment section. I'll try to clarify those. And thank you everyone. Bye bye.